So applying linear interpolation here, the length of time to the nearest minute is given in this table, and it's the length of time to the nearest minute spent on the internet each evening by a group of students, which is shown in the table. As we can see here, there is a total of the frequency which you can work out, and the total of the frequency here is 2 add 25 add 30 add the 13, and that's a total of 70. So I'll just make a note of that. Total here is 70. And what it's asking us to find is an estimate for the upper quartile. So when it wants us to find an estimate for the upper quartile, what we need to do is we need to find out what is that upper quartile position. So essentially we're finding out the 75th percent position and what is the value at that point. Or in other words, the upper quartile is the 3/4 position. So the 3/4 position of all the values. How many values do we have? Well, we have 70 values. So we're looking for what position. We're finding out what 3/4 of 70 is. Okay, and that gives us 52.5. So we're looking for the 52.5th position. That's the position of the upper quartile. Is position of upper quartile. So let's go and take a look at how we find out what this value is. So let's find out where the 52.5th position is. Now we've got a total of 70 numbers here. So we've got 2 here, then we've got 2 plus 25, we've got up to 27 here. So what I'm doing is I'm doing a cumulative frequency here. And then I've got 2 plus the 27 plus another 30, I've got up to 57 here. And if I add another 13 onto that, that gets me to the 70, which is what we expect. So where is the 52.5th position? Well, it's certainly not in this group here because this group only goes up to 27. So the 52.5th position is going to be in this group. So really what we need to do is we need to look at this group and focus on that in a bit detail. So what's the upper limit and lower limit of this group? Now, notice here that the values that we've got go from 32 to 33, and then it goes from 34 to 36. So what happens if we have 33.5 minutes? So this is where we need to do a continuity correction. Okay, so what we're going to do is instead of looking at 34 to 36, we go to the midpoint of 33 and 34. So our values for this particular group are going to go from 33.5 to 36.5, and that's me doing a continuity correction for that group, that interval. So what I'm going to write down here is length of time along the top, and I'm going to be looking at the interval 33.5 going all the way to 36.5. On the bottom, I'm going to write down what my cumulative frequency are. So I'm going to write that down to CF for cumulative frequency. So what is the cumulative frequency up to 33.5? Well, up to 33.5, the cumulative frequency was 27. And up to 36.5, which is the upper limit, it goes to 57 was my cumulative frequency. I'm interested in finding the 52.5th position. So I would indicate where 52.5 is. It's somewhere along here. I don't know exactly where it is. It's somewhere along there. So that's the 52.5th position that I'm interested in. And I need to find out what is the time at that position. So I'm interested in this value here, which is an unknown. Now, one of the assumptions made when doing questions with interpolation is we assume that the data that these 30, how many people we have from 27 to 57, we've got 30 people, they are evenly distributed from 33.5 minutes to 36.5 minutes. What that means is that there will be 30 people and we kind of spread them out evenly between 33.5 to 36.5. That's usually a 1-mark question where they ask you, what assumption have you made in working out this estimate for the upper quartile? You would write down, the assumption is, I assumed that the data is evenly distributed within each interval. So let's go and take a look at how we then work it out. There is no formula to remember or memorize. Okay, we don't learn it that way. What this is essentially, if you look at this scale that I've drawn here, I've got time along the top and I've got cumulative frequency along the bottom. And what I can do is I can set up an equation using ratios. So I can say that this distance here, which is x minus 33.5 over the total distance here, which is 36.5 minus 33.5, must be equal to this distance here, which is 52.5 minus 27 over the total distance here, which is 57 minus 27. So all I've done is I've essentially said that these two ratios must be equal because they are essentially the same number line, but I'm just looking at two different scales. Okay, so it's essentially setting up that equivalence. And it is this that you solve to find out what x is, which is the time at the 52.5th position, i.e. the upper quartile value for time. So if we go and rearrange this and make x the subject, we would have, well, let's simplify this a bit. So we've got 52.5 minus 27. So we have 25.5 here over 30 times by 36.5 minus 33.5, which is 3. And then x is equal to all of that plus the 33.5. Okay, so we've got 25.5 divided by 30 times by 3 plus 33.5, and that gets us 36.05. So x is equal to 36.05 minutes. Remember what x was? It was time. And the question asks to find an estimate for the upper quartile. So the upper quartile time we can say is 36.123 significant figures. And then it goes on to say find an estimate for the 10th percentile. The 10th percentile, again, is you need to find out where the 10th percent is. So out of 70 students that we have in total, the 10th percent is going to be the 7th student. So we need to find out the position of the 7th student. And you would do the same process again, but this time using the group that contains the 7th student, and that would be the 32 to 33 group. Again, needing a continuity correction.